Questions of life. Have you pondered on your own where we came from, what's our purpose, where we're going to? And what's more important, when you think of these things and you have some answers, are you sometimes too embarrassed to really ask somebody who's an expert in a specific field? Hey, I'm John Harris and welcome to another episode of Exponential Radio. We're going to chat today a little bit about Grok3 and the fun I'm having on it. So, some of these questions that you may not ask professors or experts, for me specifically, how was everything started? The theory of everything, the TOE. And then if you have this theory, obviously you get a little bit scared to ask professors because they tend to give you answers and ridicule you for your amateur input. So I thought I'd ask Grok some of these questions, and Grok3 is really, great fun. So I put one of my ideas in, and I said, to do with the theory of everything and gravity and gravity waves, etc. And this is what it came back to me with. So it said, let's address your hypothesis and question step by step to provide a clear and complete answer. Which is a lot better than getting somebody with a degree telling you, listen, you don't know what the hell you're talking about, when I'm only an amateur having some fun. So my hypothesis states the gravity field is intrinsic in energy. It's an intrinsic energy. This suggests that gravity is a form of energy inherent in space-time itself, not necessarily dependent on external sources like matter and other energy forms. So, at zero mass, there is zero gravity. This implies that the absence of mass typically associated with matter, the gravitational effect disappears. The gravity field exists independently of quantum mechanics, which deals with matter. So this is where I was like trying to find out. They got a big problem with unifying the theory because quantum mechanics and gravity are not compatible. And I'm trying to say, well, if you go a bit further back before you have subatomic particles and you don't include mass and matter in the fabric of space, it has no matter or mass, then perhaps that is gravity itself in its purest form in the field. And anyway, this is how we plotted on with this little questionnaire. So this proposes that gravity operates separately from quantum mechanics, which typically describes the behavior of particles and matter. So the question, how does intrinsic energy contain fluctuations? You're asking how this inherent gravitational energy can exhibit variations or changes. So this is the issue, because if you have a pure field in space, pure energy, empty space in other words, how does it that it has any ability to change? How does it now start creating subatomic particles? So there must be fluctuations, they call them banes. But how does this occur? So we plot on. Understanding the hypothesis. First, let's interpret what intrinsic energy means in the context of the gravity field. In physics, gravity is described by Einstein's general relativity, where it arises from the curvature of space-time caused by mass and energy. The phrase intrinsic energy could mean that the gravity field possesses energy. Okay, so this is now Grok chatting back to me, very patiently, I might add. And possess energy that tied to the structure of space-time itself, even without invoking matter or quantum effects. However, the statement that zero mass, there is zero gravity, suggests that mass is a key driver of gravity, which aligns with general relativity. Without mass or energy, space-time would be flat and no gravitational effects would be observed. The idea that gravity field exists independently of quantum mechanics implies a classical perspective like general relativity, where gravity is a curvature of space-time rather than a quantum field mediated by particles, etc. So it's really very interesting, because remember that AI, Grok, XAI his mission is to understand the universe, which is in the end to understand the TOE, to come to terms with it. And this is no Mickey Mouse feat, I might tell you. People that really understand this, of course I don't, I'm just playing around with it, but people that understand it know that it's very complex. We've got string theory, including quantum field now, but that seems to become obsolete, and we've got some top world-class mathematicians trying to prove that theory, and it doesn't seem to be going anywhere. But it's no simple thing, let me just tell you. So this is a really big deal. So for example, hypothetical gravitons in quantum gravity theories, quantum mechanics typically governs matter particles, e.g. electrons, quarks, and their interactions, whereas your hypothesis positions gravity as a distinct form of this framework, from this framework. All right. So addressing the questions, fluctuations in intrinsic energy. Now let's tackle the core question. How does intrinsic energy contain fluctuations? Fluctuations refer to the variations or changes in the gravitational field's energy. Since the hypothesis emphasizes independence from quantum mechanics, we'll explore this within the classical framework consistent with general relativity while respecting the conditions you've outlined. I love Grok. Gravity as intrinsic energy. In the gravity field, if the gravity field is intrinsic energy, we might consider the energy associated with space-time's geometry. In general relativity, the curvature of space-time is determined by the distribution of mass and energy via the Einstein field equations. And that is a serious equation, which I'm not even going to try to, to tell you what it means, okay? Other than E equals mc squared, where energy is equal to mass and velocity times double the speed of light, squared light. So this one is a serious one. And here, part of that equation represents space-time curvature, the gravity field. And the other part is the stress energy tensor, which includes contributions from mass and energy. When that part of the equation, no matter energy, the space-time can still have curvature in certain cases known as vacuum solutions. These solutions suggest that the gravity field can exist and have dynamics independently of matter, aligning with your hypothesis, except for the zero mass, zero gravity condition, which, well, we'll reconcile shortly. So it's really very interesting for me, okay? I mean, you know, obviously for top cosmologists and mathematicians, this would be irrelevant, but for us pure plebeians, it's great. Fluctuations in the classical gravity field. Even without quantum mechanics, a classical gravitational field can exhibit fluctuations, meaning its strength or configuration can vary over time and space. The most prominent example is gravitational waves. Gravitational waves, okay, these are ripples in space-time caused by the acceleration of massive objects, e.g. merging black holes. However, they can propagate through vacuum, carrying energy as distortions in the gravitational field. The vacuum solutions of Einstein's equations, where the first part equals the gravitational waves, represents time-varying curvature, demonstrating that the gravity field can fluctuate without matter present in the immediate region. Next, it talks about the energy of the field, okay, which we discussed when I had my hypothesis. Gravitational waves carry energy often quantified in general relativity through concepts like the ADM. The energy in specific scenarios. This energy can be seen as intrinsic to the gravitational field's dynamics. Thus, if the gravity field's intrinsic energy is tied to space-time curvature, fluctuations in this energy manifest as changes in the curvature, such as waves of other dynamical geometries. The Calabi, excuse me, the Calabi-Yau, we haven't touched, the part of the string theory and this geometric symmetry But those seem to be battling along, trying to get answers. Reconciling zero mass and zero gravity, the statement at zero mass there is zero gravity poses a challenge. In standard general relativity, mass and energy generate gravity, and even massless entities like light with energy but no rest mass. It's very interesting about a photon. It has no rest mass because it's so hyperactive. That obviously would change wouldn't be a photon if it was out of that state. So then it perhaps would have mass, but in its state it doesn't. So with light and can bend space-time. If zero mass means no matter, rest mass, but allows other energy forms, gravity could persist due to the field's intrinsic energy. However, your hypothesis explicitly states zero gravity, suggesting that without mass, the gravitational effect vanishes entirely. To resolve this, Grok. Interpretation: zero mass might imply a scenario with no matter and no other energy contributions. For example, radiation field or field energy. In this case, space-time becomes flat, the Minkowski space-time, and gravity is absent, consistent with zero gravity. However, this seems to contradict the idea of an intrinsic gravity field unless the intrinsic energy is only activated by mass. An alternative view: perhaps the intrinsic energy exists but produces no observable gravity without mass to source it. Yet, the question about fluctuation suggests the field has dynamics. Let's assume the intrinsic energy can fluctuate in principle, e.g. gravitational waves, but measurable gravity requires mass. Given the hypothesis structure, the most consistent interpretation is that the gravity field has intrinsic energy capable of fluctuations, but these don't manifest as gravity, curvature affecting objects, without mass present. Fluctuations could still occur as potential variations in the field's configuration. So let's jump onto how fluctuations occur, which is very important because in pure space, empty space, how are there bangs, how are there fluctuations within the field? And this is Grok chatting to us. In a classical non-quantum framework, vacuum dynamics, solutions to the Einstein equation in vacuum, no matter, allow for time-dependent geometries. Gravitational waves are a prime example, ripples in space-time that alter the gravitational field's local strength and structure. So field variations. The intrinsic gravity could fluctuate through changes in curvature, even if these don't produce a net gravitational force without mass. Think of these as oscillations or waves in the fabric of space-time itself. So the final answer. The intrinsic energy of the gravity field contains fluctuations through the dynamical behavior of the space-time, as described by general relativity. Even in the absence of matter, the gravitational field can exhibit variations such as gravitational waves, which are ripples or changes in space-time curvature. These fluctuations represent alterations in the field's intrinsic energy, manifesting as a time-varying geometries in vacuum solutions of the Einstein field equations. While your hypothesis states zero mass, there is zero gravity, suggesting no observable gravitational effect without mass. The field's intrinsic energy can still fluctuate through these classical dynamics independent of quantum mechanics. So in short, our conclusion, the intrinsic energy contains fluctuations via the natural classical evolution of the gravitational field, such as gravitational waves or other vacuum space-time perturbations. Man, you got to give it to Grok. This is such fun, and I hope you guys take up Grok3 and ask some of your questions.